Morning students. So today we solve some more problems on Cauchy's homogeneous differential equation. So in the last class already this problems we have done. So in this class we see some other type of problem. So this is the problem. Solve 2x minus 1 whole cube d cube y by dx cube plus 2x minus 1 dy by dx minus 2y equal to 0. Okay, so this is the problem. Now in this case what we do, we substitute or we make the substitution as 2x minus 1 equal to z. Okay, then differentiating with respect to x both sides, which gives 2 means differentiation of this is equal to 2 equal to differentiation of z with respect to x dz by dx. Now we find dy by dx. So dy by dx can be found as, so this dy by dx can be written as dy by dz into dz by dx. Okay, so that it gives dz cancel, again it becomes dy by dx. So why we have done, because x is a function of z. Now see here, x is a function of z. So that means while differentiating with respect to x, first we differentiate with respect to z and then z with respect to x. That is by chain rule. Okay. So dy by dz into dz by dx, which is equal to, now dz by dx already we found, this is 2, then substitute 2 here, so which gives 2 into this dy by dz. Similarly, d square y by dx square. So d square y by dx square is written as d by dx of dy by dx, again which can be written as d by dx of this dy by dx is nothing but what, 2 into dy by dz. So that we substitute here 2 into dy by dz. Okay, so that is d square y by dx square is equal to, now in this case what we do, again we differentiate this first with respect to z and then z with respect to x. Okay, like that we have done here, right? So first we differentiate this with respect to z, so d by dz of 2 into dy by dz, then differentiate z with respect to x, so which is equal to, now 2 is a constant, we take that out. Now d by dz of dy by dz is d square y by dz square into this dz by dx, this is equal to what, 2. So we substitute that here, which is equal to 2 into 2 4 whole d square y by dz square. Or in other words, this can be written as d square y by dx square is equal to, this 4 is nothing but 2 square d square y by dz square. Okay, similarly, on observing these two, d cube y by dx cube becomes 2 cube d cube y by dz cube. So now substituting all these derivatives, substituting all this dy by dx, d square y by dx square and d cube y by dx cube in equation 1. So that is what in the given problem. So here we have to substitute. So first what we have to substitute, 2x minus 1 is equal to z. This we have to substitute. So this becomes z cube. Okay, then d cube y by dx cube and then dy by dx, all we substitute there. So we obtain this equation, z cube 2 cube d cube y by dz cube plus 2z dy by dz minus 2y equal to 0. On simplifying this, 8z cube d cube y by dz cube plus 2z dy by dx minus 2y equal to 0 we get. Okay, so now we have converted into a standard form now. So now we apply the method, that is put z is equal to e raised to u, which implies u is equal to log z. Okay, so now we find z cube into dz d cube by dz cube is same as d1 into d1 minus 1 into d1 minus 2, where d1 is differentiation with respect to u. Next, z into d by dz is nothing but d1. Now substitute again all these in this equation, where here in this equation. So we get 8 into d1, d1 minus 1 into d1 minus 2 plus 2 into d1 minus 2 y equal to 0. Again multiply these two, all these factors and all this, and we write this equation. So finally we get this equation, and again we simplify this, which gives 8 d1 cube, this minus 16 d square minus 8 d square, it gives minus 24 d square, minus 24 d square. Similarly here, plus 16 d1 plus 2 d1, it is plus 18 d1, then minus 2 y equal to 0. Okay, so now therefore we write auxiliary equation. Auxiliary equation is 8m cube. So just replace d1 by m, 8m cube minus 24m square, then plus 18m minus 2 equal to 0. Okay, so now in this case, this is a cubic equation. Now we want to find the roots. So now this is a cubic equation, means it has 3 roots, right? It has 3 roots. So we have to find all the 3 roots. So how to find that? Okay, so now to find the 3 roots, first what we do, we find one root by inspection method. By inspection method means what? We substitute or we check for which values of m this equation is going to satisfy, or this equation is going to be 0 for which value of m. So just we go on substituting m is equal to 0, 1, 2, 3, 4 like that. So we find one root. So on substituting m is equal to 1, now see here, this is 8 into 1, 8 minus 24 into 1, 24 plus 18 into 1, 18 minus 2. So when you substitute m is equal to 1, 8 minus 24, it gives minus 16, then 8 minus 2, it gives plus 16, so minus 16 plus 16 get cancelled and it gives 0. So therefore for m is equal to 1, this equation is going to satisfy. So m is equal to 1 is one root. Next we find the other 2 roots. To find other 2 roots, so what we do, we apply synthetic division method. The synthetic division method is what? So first what we do, we write all coefficients of all m cube, m square, m and so on. Now see here in this case, coefficient of m cube is 8, we write here first. Then coefficient of m square is minus 24, so we write that is second. Next coefficient of m is plus 18 and the constant is minus 2. Okay, so like this we write the coefficient of all m square, m cube, m and all that in a descending order. Suppose that in some problems, we may not get some terms here. That is, we may not get m square term, or we may not get m term. If suppose that m square term is not there, okay, then you take coefficient as 0, right? Then you take that coefficient as 0. So that means like m cube is 8, so m square, if there is no coefficient of m square, then you take it as a 0. Then m means, suppose m has a coefficient say 6, then write 6. Then if minus 2 is there, then write minus 2. Okay, so like that. So here all the coefficients are present, so m cube, m square, m and constant. So we write all the coefficients here, 8 minus 24 plus 18 and minus 2. Okay, after writing this, next what we do, we below the first element, so means below this element, we take that as 0, we write 0. Okay, and then what we do, we add these two, so 8 plus 0 means 8. Okay, after adding these two, then multiply this 8 with this 1, so 8 into 1, 8, and we write that element below the second element, means here 8. So now minus 24 plus 8 is minus 16. Add these two, minus 16. Again what we do, after adding, multiply this minus 16 with this 1 and write it below the third element. So minus 16 into 1, minus 16, and I'll write minus 16 here. So So now 18 minus 16 equal to 2. Okay, 18 minus 16 equal to 2. Next, after adding these two, again we multiply this 2 with this one and we write it below the next element. So that is 2 into 1, 2, we write here. So now add these two, we'll get this as 0. So this last element we should get 0. Then only whatever we done, that is correct. Otherwise it is wrong. Okay. So then these becomes the coefficient of the quadratic equation. Means we are reducing, by applying synthetic division method, we are reducing cubic equation into a quadratic equation. Okay. So now these becomes the coefficients of quadratic terms. That is this is a coefficient of the highest term, that is m square, and this is a coefficient of m, and this is a constant. So therefore we write this as 8m square minus 16m plus 2 equal to 0. Now taking 2 common, so we get 4m square minus 8m plus 1, that 2 goes to 0, so that is 0. Next we find this roots, either you apply that is minus b plus or minus b square minus 4ac by 2a formula, or you can apply a factorization method, whatever you apply. So then you find two roots, so m is equal to 1 plus or minus root 3 by 2. That is, first root is m1 is equal to 1 plus root 3 by 2, and the second is m2 is equal to 1 minus root 3 by 2. So two roots you are getting. So after finding the two roots, we find the general solution. Now the general solution is gs is equal to c1 e raised to u. So now here e raised to u means we got three roots. The first one is m is equal to 1. This is the first root, and these are the two, the second and this is third root. So three roots we got. So therefore the general solution is c1 is equal to, for the first root c1 m1 u, m1 is 1, c1 e raised to u plus c2 e raised to m2 is 1 plus root 3 by 2 into u plus c3 e raised to m3 is 1 minus root 3 by 2 into u. After obtaining this, resubstituting u, so u as log z, and substitute here, we get gs is equal to c1 e raised to log z plus c2 e raised to 1 plus root 3 by 2 into log z plus c3 e raised to 1 minus root 3 by 2 into log z. Okay. So now after obtaining this, now here this is capital, this is log z to the base e. So this e and e get cancelled, and it gives c1 z. And similarly here plus c2, here this is of the form m log n. That means this can be written as log m raised to this term. So that is log z raised to 1 plus root 3 by 2. So here z to the power e, z to the base e, and this e get cancelled, and it gives z to the power 1 plus root 3 by 2 into c2. And similarly here, this is again m log n, log z raised to n. So log z raised to 1 minus root 3 by 2. So this e get cancelled. So it gives 3 into z to the power 1 minus root 3 by 2. Okay. So this is the general solution. So this is general solution, and this is also the complete solution, because here we don't have to find a particular integral. Why? Because in this given problem, see this is a given problem. In this here the right hand side is 0. The right hand side is 0. If the right hand side is 0, then it has only general solution. The given equation has only general solution. If the right hand side is equal to 0, then no need to find particular integral. If suppose right hand side is not equal to 0, if it is some constant, or if it is a function of x, or if it is a function of trigonometric function, or if it is a any other function, then what we do, we find the particular integral, and we apply those rules depending on the nature of the function. Okay. So therefore here we need not have to find a particular integral, therefore only it has only general solution. So that is equal to what? So this is the complete solution of the given problem. Okay, so with this I conclude this class and continue in the next class. Thank you.